So I will start with the chapter, okay? Though I have done this chapter completely with a few of you, but there are new students as well who have joined us today, and also that you guys needed a revision. So I decided that I will start this chapter from the beginning. So let me start. Okay. Okay, first of all, keep your eyes on the screen that I'm showing. First of all, this is one basic question. What are acids? We're doing acids and alkalis, right? So what are acids? Now, I won't ask you. I'll just straight away enter into my explanation. Substances that give hydrogen ions when dissolved in water. They are also called proton donors. They give hydrogen ions when dissolved in water. What do I mean by that? Now, I'm giving you an example of a simple acid, which is hydrochloric acid. It is simple because it has only 2 atoms involved, so it's good for my explanation. Now, as the definition goes, they are proton donors or hydrogen ion donors, right? Now, of course, for a substance to be able to give hydrogen ion, it should have hydrogen at the first place, right? If it doesn't have hydrogen, how will it give? So that is why in most of the formulae of acids, you will see that there is hydrogen written at the beginning of the formula. Hydrogen always comes first in the formula of any acid. Okay, this is the hydrogen which is given in solution, which is responsible for their acidic properties. If a substance cannot give hydrogen ion for any reason, it cannot be acidic. Now, how do these molecules give hydrogen ions when they dissolve in water? I have tried to make this diagram. First, look at this. Okay, look at this part of the diagram. Okay, look at this. This is hydrogen. This is chloride. Chlorine atom. This is chlorine atom. This is hydrogen atom. Now, these are water molecules surrounding it. Okay. Now, I have discussed the molecule of water with you guys. Okay, this big circle is the oxygen atom. We know this. This is oxygen atom, and these small blue colored ears, these are hydrogen atoms. Okay, these are hydrogen atoms. So this is our water molecule. Now, I told you because oxygen is more electronegative than hydrogen, meaning that it pulls the electrons towards itself. See, this is how the molecule is, right? When it comes to the covalent bonds, right? There are 2 covalent bonds between hydrogen and oxygen, right? So there are 2 electrons. Remember, all the bonds are composed of 2 electrons. 1 electron contributed by this atom, the other one contributed by the other atom. Together they share, and so that's how they make a covalent bond, right? So that's exactly how the bonds are in the water molecule. But the atom, which is more electronegative, what do I mean by electronegative? Meaning that it has a stronger pull towards these electrons, meaning oxygen pulls more of these electrons, so much so that it even pulls these electrons towards itself. Let me use a pencil. You know, like it tries to pull even the other electron towards itself here as well, because it is so electronegative. Okay, because it is so electronegative, it pulls all the, I mean, not all, but both of these electrons present in the bond towards itself. Okay, I hope you're getting the picture. So like it has more of the electron cloud towards itself. Okay, electrons, think of electrons as clouds. Think of electrons as clouds. So that pulling gives oxygen a negative charge, as you know, like a partial negative charge, and hydrogen partial positive charge. Not, why am I saying partial? Is because these charges are not complete. Okay, it's not like hydrogen has completely lost an electron and oxygen has completely gained 1 extra electron. That hasn't happened. There is still this is still a molecule, not an ion, and there is still some sort of sharing. You know, it's like a bigger brother and a smaller brother sharing a bed sheet, and the bigger brother, because he's bigger and because he's stronger, he pulls the bed sheet more towards himself, but there is still some bed sheet left on the smaller one, but the smaller one has less of bed sheet compared to the bigger one. I hope you're getting my point. So all these partially positive hydrogen atoms are attracted towards this negative. This is chloride is highly electronegative, meaning that it is negatively charged. It has a lot of attraction for electrons. So because this is negative charge and there is attraction between opposite charges, these partially positive part of the molecule is attracted towards this negatively charged ion, right? Like these positive part. So the hydrogen part of the molecule, if you divide the molecule into two, you can have, you know, like this is the positive half and this is the negative half. So the negative half is sticking out. The positive halves are facing towards this negatively charged anion, right? Now the opposite is happening with hydrogen because this is positive charge. Because hydrogen is a cation, it is a positively charged ion. Therefore, the negative part of the molecule, it is the negative part of the water molecule which is attracted towards this positively charged cation. Again, you can, you know, divide the molecule. The negative half of the molecule is facing the positively charged cation. So as now you can see how the molecules have arranged themselves around the cation and the anion of hydrogen chloride. Eventually, they pull the two out. They pull the two away from each other. Something like this. See, initially they were sharing these two electrons. These were the two electrons that they were sharing, right? This was the covalent bond. Now, the two have separated. This is the separated form. This is the separated form. This electron that was initially hydrogens has been completely pulled away by the chloride. Why? Because chloride has a stronger affinity for the electron, right? And hydrogen has lost because it is not strong enough to hold on to its electron, right? So this now, initially it had 7 electrons, right? 1, 2, 3, 4, 5, 6, 7. It had 7. The blue colored electrons are chlorine's own electrons. That's why it is in the 7th group, because it has 7 electrons in its outermost shell. But now it gained 1 more electron from hydrogen atom. So that gave it an extra negative charge, made it chloride. And this had one electron only. And now it has lost that 1 electron. So only the nucleus is left behind with no electron at all. And the nucleus has 1 proton, which is positively charged. So it is left behind with 1 positive charge on it. It is this hydrogen ion which is responsible for the acidic behavior or the acidic properties of an acid. Now, what are those acidic properties? We will discuss them later, okay? But you should understand this. This is why water is essential for any substance to be acidic, because until and unless these water molecules are not surrounding the acid and they are not pulling the ions away from each other, they are not separating them, we won't get hydrogen ions in the solution which are responsible for the acidic behavior. I hope I made sense. Okay, if anything is unclear, ask me from what I have just explained you. Is there any question? Beta, I have been announcing in group again and again, we are doing acids and alkalis. Okay, I don't know the chapter number in your book. I have the old book, but we are doing acids and alkalis. Yes. Okay, is there any question? Or should I move on? Okay. Okay, so you understand this, right? Substances that give hydrogen ions when dissolved in water also called proton donors. Why? Because hydrogen ion is basically just a proton. It's just a proton, nothing else. It has no electron, no neutron. It doesn't even have a neutron in its nucleus. Okay. Now the most common and the strong acids that we come across in chemistry, in ordinary chemistry of O levels, is hydrochloric acid, nitric acid, and sulfuric acid. And it is helpful to remember their formulae. And if you do not know how to write formulae, then let me know. We will arrange a class on how to write formulae, right? And how to balance equations. So these are the formulae you should remember: hydrochloric acid, nitric acid, and sulfuric acid. Okay. Then what are bases? That was acid. Now what are bases? Okay, what are bases? Acids were hydrogen ion donors, right? Or proton donors. Bases are just the opposite. They are substances that accept hydrogen ions. Okay, one is giving. If one is giving, there should be another who is taking. If there is nobody to take, who will the acid give to, right? So if we have acids, they should be reacting with some bases which can accept those hydrogen ions. Okay, they usually have OH at the end of their formula. Okay, this OH is representing the hydroxide anion, which basically accepts the proton, which the acids are giving it, to form a water molecule. Now, water molecule is a simple covalent molecule. It does not have any ion, okay? Though it might have partial positive and negative charges, but it is not an ion. It is a simple water molecule, simple covalent molecule, okay? So when the hydrogen ions react with the hydroxide ions, hydrogen ions come from the acid, hydroxide ions come from the base, we get neutral water molecule. Okay, we get neutral water molecule. Why am I saying neutral? Is because this is neither acidic nor basic. Okay, acid is due to hydrogen ions, base is due to hydroxide ion. Water molecule has none of these, has no charged particle, therefore this is neutral. It has no hydrogen and no hydroxide. You know, it's like minus reacting with plus to give you 0. Okay, it's like that. You can think of it as that way. -1 and then +1, they get cancelled out to give you 0. Something like that. Okay, so this is neutral, meaning it has no charge on it. This is +1, -1, giving you neutral water molecule. Okay. Now, bases can be soluble or insoluble. Okay, soluble meaning dissolved in water, insoluble meaning that cannot dissolve in water. So soluble bases are called alkalis. They have a special name called alkalis. Okay, the insoluble ones are just simple bases. Okay, now alkalis are also bases. We cannot say that alkalis are not bases, but it's just that alkali are soluble bases. So that's that. There is nothing difficult about it. So all the alkalis are bases, okay, because basically they were bases, but they were soluble. That's why we call them alkali. But all the insoluble bases are just simple bases. We will not call them alkali. Okay, so nothing to be confused about that. Okay, after this basic concept, this I have already explained you that acids need water. Why? I have already explained this, that the water, now here you can see that the oxygen atom has these lone pairs of electron hanging out, and they are the ones which get attracted towards the positively charged hydrogen, and therefore they pull the hydrogen out and they separate these hydrogen ions from the chloride ions, and these hydrogen ions are then responsible for the acidic properties. So if hydrogen chloride, now hydrogen chloride is a simple covalent molecule. It is a simple covalent molecule, meaning that it is not an ion. If it is not dissolved in water, it's a molecule. It is neutral. Okay, that's why hydrogen chloride gas will not give you acidic properties. Only when it is dissolved in water will it give you acidic properties. Okay, we will discuss that. I mean, we will discuss the acidic properties in detail later. Okay, so because they are still covalently bonded to each other, the hydrogen ion is not free. Therefore, the hydrogen chloride gas will not give you acidic properties, because this is how the hydrogen chloride gas exists. This is the hydrogen chloride molecule. Okay, then now the first page in your book, which is this, the first page in your book, which is this, okay, these pictures, these are examples of weak acids. Okay, these are examples of weak acids. Now, what makes an acid weak or strong? What do we mean when we say strong acid, weak acid? What does it mean? Now, the simple explanation is that if, for example, we have 100 molecules of an acid, any acid, okay, for example, we have total of 100 molecules, just suppose. And out of those 100 molecules, out of those 100 molecules, 98 molecules ionized. 98 molecules ionized, meaning that only 2 were left unionized, 2 were left in the molecular form. The rest of 98 of them, they split, they're dissociated into hydrogen ions and chloride ions, right? So that means the ratio is pretty big. That means almost all of them ionized to give hydrogen ion. So that means the concentration of hydrogen ion must be pretty high. That makes an acid a strong acid. Okay, and this reaction is not even reversible. It will not go back, meaning the hydrogen ions will persist in solution. They will stay in solution, right? So this is what we mean by strong acid, meaning a large portion of the acid molecules will contribute towards hydrogen ions, meaning a large proportion of water molecules will give you hydrogen ion, as a result of which the concentration of hydrogen ion would be high. Okay, remember, we're dealing with hydrogen ions the most in this chapter. Okay, concentration of hydrogen ions. Now, what is a weak acid? Now, this is an example of a weak acid. Now, don't be confused by this structure that I have made. It's okay, don't have to concentrate on the whole molecule, just concentrate on the hydrogen part, this hydrogen that I have circled with red. Concentrate on this, because this is the hydrogen which will be released in solution. Again, this also needs water to dissociate into ions, just as hydrogen chloride needed water. All the molecules require water molecules to dissociate them into ions. Dissociate means break into ions. Okay, dissociate, the word dissociate means to break. Okay. So in a weak acid, for example, if the total, we had 100 total molecules, only 2 or 3 will ionize. Only 2 or 3 will ionize. The rest of all of them will stay in the molecular form. That means only 2 or 3 molecules will ionize, and even those 2 or 3 might combine back together to form the molecule again. Meaning that at any given time, the concentration of these hydrogen ions will be too low. Concentration of hydrogen ion will be too low. Therefore, we call such an acid a weak acid. Okay? I'm repeating myself. A weak acid is when very few molecules out of the total, only 1 or 2 or 2 or 3 molecules break into their respective ions, giving hydrogen ions, and therefore the concentration of hydrogen ion will be too low, making the acid weak. And even those 2 or 3 ions may combine back to give you the molecule back, so that will further lower the concentration of hydrogen ion, making this a weak acid. Now, remember, hydrogen ion is a really powerful ion. It is responsible for one of the most vigorous and dangerous reactions in a chemistry lab. Okay, reason being, this is 1 proton alone with one whole big positive charge on it. So that means one whole big positive charge is concentrated on a very small subatomic particle called proton. You know, proton is even smaller than an atom. Even smaller than an atom. Nobody has seen a molecule. Do you know that? Nobody has ever. No scientist has ever seen a molecule, leave alone an atom, and leave alone a proton. So proton is within the nucleus. So you can imagine how small that is, and it has one whole big positive charge sitting on it. So you can see how concentrated the positive ion is, and that is responsible for all the strong reactions that acids carry out, right? Now, weak acids, since the concentration of hydrogen ion is less, as I told you, out of 100, only 2 or 3 ionize. Therefore, weak acids can be used in food because they give you that tangy taste. It makes the food tasty, right? For example, vinegar. The tangy taste of vinegar is due to acetic acid, okay? Now, the tangy taste of oranges, lemons, that khatta taste is due to these acids, these hydrogen ions, again, hydrogen ions. But these are very weak. They are like sort of this. They're like this reaction, okay? Meaning out of 100, only 2 or 3 will give you hydrogen ions, and even that is reversible. So that's why it is safe to use these acids. So they give you taste and they are safe to be used, right? And then achar also has vinegar added into it. So that sour taste is also due to acid, hydrogen ions. Now, another example of weak acid in nature is rainwater. Rainwater. Now, in rainwater, carbon dioxide reacts with water. Now, this carbon dioxide is from the atmosphere. Okay, the atmosphere has carbon dioxide in it, which reacts with water to give us carbonic acid. This is called carbonic acid from the word carbonate. It has H2CO3. So H2CO3. H2CO3. This carbonic acid, again in water, it will dissolve in the rainwater to give hydrogen ions and bicarbonate ions. Okay, just a rough idea of what is happening. This is H2CO3. This whole ion is carbonate, 2 hydrogen atoms bonded to it covalently. Now, again, when it dissolves in water, they separate. So HCO3 and this hydrogen got pulled out as hydrogen ion. This hydrogen ion is responsible for the acidic behavior. Okay, this reaction takes place in rainwater as well as soft drinks. That's why if you read the ingredient list on the bottles of soft drink, the first on the list is carbonated water. What does carbonated water mean? Carbonated water is this: carbon dioxide combined with water giving you carbonic acid. That's what they mean by carbonated water. Okay, and then it gives you hydrogen ions, very few, concentration is low, to give you that feeling of, Pepsi and, all those soft drinks. Right. So now you have understood acid, you have understood base. Any question before I move on? Let me ask you, is there any question you want to ask? Please use the chat window if there is any question. Are you guys understanding? Should I move on? Please respond to me in the chat window, or you can raise your hand if you need to ask a question. Raise your hand if you have any confusion whatsoever regarding what I just explained to you. Is the rainwater salty? No, well, it depends upon what minerals are there in the atmosphere, which might, combine together to form salt. But I will not discuss salt for now. This class, in this class, I will confine myself to acids and alkalis. And then in the next class, we will discuss the salts, okay? So for now, I want you to understand what acids are, why acids need water, what bases are, right? And then now I will move on to the reaction between the two. Okay, Amara, please explain cation and anion, please. Please repeat the reason for dissolving acids in water. Ibrahim, I explained in great detail the dissolving of acid in water. Look at this. Okay, you can even listen to my recording again. Okay, I think if you will listen again to my recording, things will make sense to you. Okay, keep this diagram in mind. Okay, this is how they dissolve. How does anything dissolve? When the ions are surrounded by water molecules. When the substance gets into the space between the water molecules, that's when we say that this substance has dissolved. The word dissolve means that the substance which is dissolving should get into the space between the water molecules. That's called dissolving. So when they are surrounded by water molecules, meaning that they have gotten in between the water molecules. This is what I mean by dissolving. Now, cation and anion. Amara, okay, real quick, I will deal with this, cation and anion. Haven't you guys done this in first term, cation and anion? Haven't you guys done cation and anion in midterms? Okay, for example, chlorine. No, you guys have not done cation and anion in midterms. Oh my God, I mean, then I cannot imagine doing chemistry without knowing cation and anion. Oh my God. Ions was not included. Okay, okay. Okay, I'm showing my video. Okay, this is chlorine. Okay, this is chlorine atom. For example, this is the nucleus. Okay, this is chlorine is in which group? Chlorine is in group 7, right? We know, have you guys done periodic table? You guys must have done periodic table, right? So you know that the group number is the same as the number of electrons in its outermost shell, right? So if this is group 7, that means there must be 7 electrons in the outermost shell of all of these atoms, right? So I'm not drawing the whole atom, I'm just drawing the outermost shell, which is let me make another one here. Okay, it has 7 electrons. 1, 2, 3, 4, 5, 6. Do you know how the electrons sit on the atom? Let me tell you an interesting thing. Have you ever noticed how children sit in the van, or when how people sit in the bus when they enter an empty bus? Everybody wants to sit near the window, right? So everybody will first sit near the window. When all the window seats are occupied, and if there are more people coming into the bus, they will then have to sit next to the person who is sitting near the window, because they don't have any other option, because all the window seats have been occupied. Same is the case with these electrons. They want to have freedom. They want to have a lot of space to themselves. So they will occupy, there are 4 seats, 4 sort of, seats. So each electron will come and sit alone first, because they want to have freedom. Then there are more electrons to come. They don't have any other option, no more seats left. So they will come and sit next to whatever is available to them. So this is how the outermost electron looks like, okay? Chlorine has 17 electrons. I'm not drawing all 17, just the outermost electron, right? Now, how many how many protons does chlorine have? 17 protons, okay? And it must have 17 electrons, right? It must have 17 electrons. Okay, I'm making the inner ones also so that you understand. So these are this is the innermost 2 electrons, then the outermost. Again, they will sit one single first, then they have to pair up. So they're pairing up like this. So this is my chlorine atom, right? Now this has 17 protons, 17 positive charges, and 17 electrons, 17 negative charges, right? So 17 plus 17 minus gives me 0, right? So neutral atom, right? Now, if it gains 1 electron, and I'm drawing this with a red marker because this came from, let's suppose, hydrogen and hydrogen chloride. This electron is gained from hydrogen. Now, proton number is still the same, okay? 17 proton, and protons are positively charged. So my positive charges are still the same, but negative charges are now 18, not 17, because now it gained 1 more from hydrogen, right? So now it's 18. So now the net charge is 17 minus 18 is -1. So this gives a negative charge to this chloride. That makes this a chloride anion. Anion. Okay? An means negative. Negatively charged ion. Ion is any particle, any charged particle. Ion means charged particle. If I say ion, I just mean charged particle. Whether positive or negative will be decided by whether I'm using an ion. An ion would mean negative charged particle, negatively charged particle. And if I'm using cation, now let me explain you cation. Let me take the example of hydrogen. Hydrogen has only proton in its nucleus, no neutron. It has only 1 proton in its nucleus, okay? Now, this is the nucleus, and then it has only 1 electron in its shell. That's that. So, proton is positively charged, +1, -1, electron is -1, right? So, total is 0, neutral atom, right? Now, if it loses this electron, away, and now it is left behind with only 1 proton in the nucleus and with nothing, there is no electron, lost it. So this is that. So now it's only +1 with nothing to balance it. Okay, you can just say 0, -0 or +0 doesn't matter, you will get +1. Okay, so this has a net +1 charge. So this is again an ion because it has a charge on it. It is a charged particle, and it is a cation. Cat means positive, positive. It is a positively charged ion. Did you understand this? So hydrogen ion is a cation, and negatively charged anion example is chloride ion. Did I make sense? Amara, did you understand? Please, okay, let me, Amara, I'm unmuting you. I'm unmuting you, Amara. Let me know if you understood. You're not getting unmuted. Okay, Ibrahim, you understood. Okay, good job. Fawad, did you understand?
Teacher?
Fawad? Yes, did you understand cation and anion?
Yeah,
Yes.
I did understand, but we weren't supposed to study ions.
Yeah, we were not supposed to study ions, exactly. But the children are saying that they don't know. Like they don't know cation and anion. And how can I explain you acids and alkalis if you don't know ions? Yeah, that's the thing.
So we weren't. So we shouldn't study ions. That means we did it
No,
by mistake.
no, you should. What do you mean? No, you have to understand ions. I mean, it's just like ABC. If you do not know ABC, how can you write words? If you don't know words, how can you write sentences? If
I
you
know
don't
we
know how,
about ions, but we shouldn't be doing it in this syllabus. That's what I'm asking.
beta, I don't know if there's an ion chapter in your book or not. I don't think there is, but it's just like you are being tested on writing an essay and you don't know how to write words. It's just like that. If you cannot write words and if you cannot write sentences, how can you be assessed on writing an essay? That's absolutely absurd. That cannot take place. I mean, that cannot be happening. Okay, if you don't know ions, then you will not understand hydrogen ions, and if you do not understand hydrogen ions, you cannot understand acids. Okay, the sequence, that's how the sequence goes. Okay, if I use any term and you have not heard that term before, please let me know immediately in the chat window or raise your hand. Okay, because I don't know what have you guys done and what have you guys not done. I don't know. I'm just simply plainly doing the topic, this acids and alkalis. But if there is any concept that you do not know, if there's any term that I'm using and you did not know, let me know in the chat window. I will explain that first. Okay, because you cannot be jumping on to writing essays without knowing how to write words and how to write sentences. Do you understand that? Yes. Okay. So did you understand the hydrogen ion thing then? Now did you understand? So then you must not have understood this thing. Then you must not have understood how this hydrogen chloride dissolves in water. You must not have understood all of this when you did not know what cation and anion were. But now is it making sense? This chloride had negative charge on it. I'm repeating myself. This hydrogen had positive charge on it. This positive charge is surrounded by the negative parts of the water molecules, whereas this negatively charged part of the molecule is surrounded by the positive part of the water molecule. Now, why are these parts positive? Why is that part negative? I hope you guys know that. I just hope that you guys know that. That's the, okay, tell me something. I will ask you. I want to know. Tell me, can anybody explain me the dissolving of hydrogen chloride by water? Just repeat what I just explained. Who will? So that I know that you got my story. Who is going to volunteer to repeat the dissolving of hydrogen chloride in water to give hydrogen ions? Who is going to do that? Please raise your hands. It's okay to be wrong. It's okay. It will give me an idea of whether you are understanding what I'm explaining you. I cannot see any hand raised. Come on. Come on, I need volunteers. Then I will move on and you guys wouldn't understand. Then how is this gonna work? Should I ask anyone? Okay, Hassan. Okay, Ibrahim, good job. Thank you. Yes, Ibrahim. I'm unmuting you, but you are not yeah, okay. Yes, Ibrahim.
The covalent bond of hydrogen chloride will be broken by the H2O molecules present in the water. The oxygen will take away the hydrogen, while the hydrogen molecules will take away the chlorine. Then they both will be separated hydrogen will have no more atom left, and the molecule of the hydrogen will go to chlorine. So
Yes. Okay, good. Yes, Ibrahim, good job. That was a very good try. I liked it. Yes. Thank you very much. Jazakallah khairan, Ibrahim. But the only change I would bring to Ibrahim's explanation is that he's saying hydrogen molecules. By the hydrogen molecule. No, these are hydrogen atoms. Atoms. What's the difference between atom and molecule? Another question. Hassan, you want to answer that? What is the difference between atoms and molecules? No? You lowered your hand? Come on. Now this you guys must have done in midterms. Atoms and molecules, or was that also not included? You know what? I feel like starting chemistry from the beginning, you know, from the first chapter. Should I do that? Yes, Hassan?
Teacher, atoms join to make molecules, so molecules are bigger and atoms are smaller.
I cannot hear you. Can you please repeat yourself?
Atoms combine to make molecules, and molecules are bigger and atoms are smaller.
Yes? Yes, Ibrahim, I'm listening.
atoms are formed when there are less than two molecules. Yes. An atom is an atom is okay. Molecule is formed of more than one atom. An atom is just a single atom.
Yes, okay, yes, you're close. You have the idea. Yes. Yes, atom is, you know, a single atom. You know, this, you have done this, the structure of atom. Like, for example, this was one atom. This is one atom. Okay, this is one atom, like just chlorine, that's it. Okay, now when it bonds with another atom and forms the smallest particle that something is made up of, this is called a molecule. When it bonds with another atom and forms the smallest particle which is responsible for the properties of a substance. For example, this is a molecule of hydrogen chloride. So a molecule can be made up of two, one, or even more than two types of atoms. Okay? But atom is only just one type, one element. Okay, this is a list of all the elements. This is the periodic table. This is the list of all the elements. Okay, and they are all, I mean, we're talking about, these are the types of atoms that we have. Okay, on Earth, these are the main types of atoms that we have. Okay, so at least Ibrahim has understood. I don't know about others, but okay, let me move on. Okay, neutralization. Now, we understood hopefully acids and bases. Now, as I told you, as hydrogen ions from the acids and hydroxide ions. Now you understand what ions are. Now this is an anion, negatively charged particle, cation, positively charged particle, combining together to form the neutral water molecule. Now this is a molecule, meaning that there is no net charge. Whatever positive and negative charges it might have, they're all cancelled. You know, this is a water molecule. This is a water molecule, simple. No charged ion, okay, simple molecule. It is a reaction between acid and base where hydrogen ions are given by the acids, and these hydrogen ions are then accepted by the bases, by the hydroxide ion of the bases to form neutral water molecule. So remember, this is the equation, the net equation for any neutralization reaction, any, okay? No matter what acid, what base, what alkali you are using, this is the net equation for any neutralization reaction. Hydrogen ions combining with hydroxide ions to give us water molecule. And then there is salt as well here, but this is the net equation for a neutralization reaction. Net equation for neutralization reaction. Okay, so neutralization is reaction between acid and bases to give us neutral water molecules, and salt as well, but we will talk about salt later. Okay, so let's move on. Now, how do we find out how acidic or how basic a solution is? How acidic, meaning we talk in terms of hydrogen ion concentration. Basically, we talk about hydrogen ion concentration. We can talk about this in terms of hydroxide ion concentration as well, but this is more common. Okay, this is more common. As the hydrogen ion concentration increases, the solution gets more acidic. More the hydrogen ion concentration, more acidic the solution is. Okay, less the hydrogen ion concentration, less acidic the solution is. Okay, Riaz, you want me to repeat neutralization? Okay, neutralization is a reaction between acid and base. Basically, the ions that are under question, the ions that actually participate in the reaction are hydrogen ions from the acid. That's what makes them acidic, right? And hydroxide ions from the bases. They accept the hydrogen ions. Remember, bases are substances that accept the hydrogen ions, and hydrogen ions are and acids are substances that give hydrogen ions. They react together. So this is giving, this is accepting. एक दे रहा है, दूसरा ले रहा है, ठीक है? To give us neutral. Okay, remember I told you, look at it as +1, -1, giving us 0. So neutral. Like nothing, no hydrogen ion, no hydroxide ion, no ion. This is simple covalent molecule neutral. Neutral meaning, what do we mean by neutral? No hydrogen ion, no hydroxide ion. Or they are equal, so they are canceling each other out. No charge, no net charge, no net charge. Why am I using the word net? There might be charges. There might be charges, but if you add them up, you'll get 0. So net is important. No net charge. Did you understand? Okay. Now, how acidic, how basic has to do with the concentration of hydrogen ions. Okay. So keep yourself limited to hydrogen ion concentration. Higher the hydrogen ion concentration, more acidic the solution. Less hydrogen ion concentration, less acidic. Okay. Now, how do we measure the hydrogen ion? What scale do the scientists use to measure the hydrogen ion concentration? Now, we have this term pH. Okay, this is how you write pH. Okay, I have seen many students write pH like this. Please don't write pH like this. Okay, I don't like it at all. This is how you write pH. A small p, capital H. Small p, capital H. Why? Because it stands for potential of hydrogen. It stands for, let me show you. pH stands for potential of hydrogen. What do I mean by potential? It is just a scientific term for concentration. Concentration of hydrogen. Okay, potential means concentration of hydrogen. Okay. In advanced math, you don't have to deal with it. Okay, in advanced math, this is an advanced mathematic term. Okay, but you should know what it means and you should know how to write it. Okay. Okay. So this is our pH scale. Okay, this is also, I think, given in your book. This on page 100 and I don't know the page number, but this page, this. Okay, because the page number is different in the new book. Okay. So this is my scale. The lowest is 0, The lowest value is 0. The highest value is 14. In the middle, we know half of 14 is 7. Between, if you have pH of hydrogen between 0 to 7, I mean, if you have pH between 0 to 7, the solution is acidic. I'm using a red color for acidic. Okay, and if the pH of the solution is between 7 and 14, the solution is basic. Basic means less hydrogen ions. Now keep this equation in your mind. This equation in your mind. Okay, if you have pH between 7 and 14, what does that mean? That means there are more of this, there are more of this and less of this. You have more of this, less of this. So pH is from 7 to 14. And if a solution has equal hydrogen ions and hydroxide ion, both of them are canceling each other out, you have neutral, which is 7. Okay, now we use indicators. Indicators, don't be confused. Indicators are just chemical substances that change color according to the pH. So we use their color change in order to predict whether a solution is acidic or basic. Okay, the most commonly used are universal indicator. The universal indicator colors are given on this page. Okay, acidic, the color becomes darker red. Alkaline, the color becomes darker purple. Okay, from blue, light blue, dark blue, then violet, and then eventually purple. Okay, neutral, it's a green, light green. Light green is neutral. Okay, solving questions again and again, you'll remember these colors, right? Another indicator that we use is litmus paper. Litmus paper is easy. In acidic, again, it gives you pink. In acidic, it gives you pink. In basic or alkaline, it gives you blue. So if you are doing this for the first time, you might be, like mind boggled that how will I learn these colors? But trust me, you will learn them with time. Okay, yes, in the beginning, you get overwhelmed, like, I have to learn so much, these symbols of elements and these formulae, and, their charges and, their colors and this and that. But trust me, the more you will read, and I would recommend reading from different books, the more you will read, watch YouTube videos on these topics, the more you will come across the same matter again and again. Things will start getting registered into your mind, and it'll be easier for you to understand, and it'll be easier for you to remember. Like, these things are now on my fingertips. Why? Because I have been, reading and explaining so many times that now I know it. Okay, so same will happen to you as well, inshallah. Okay, now, so I want you to look at this pH thing as this seesaw. I like this analogy of seesaw that they have used in here. Okay, now your seesaw is basically this equation. When the pH is too low, what does that mean? That means we have a lot of hydrogen ions. We have a lot of hydrogen ions as compared to hydroxide ions. Therefore, okay, remember another thing which I used to get confused when I was a student. It's the opposite way, the higher the concentration of hydrogen ions, the lower the pH. Okay, isn't that confusing? pH should be like this is increasing, but pH is decreasing, but that's how it is. Okay, low pH means high concentration of hydrogen ions, so they go opposite way. Higher the concentration of hydrogen, pH is low, but don't get confused. Okay, higher the pH meaning low concentration of hydrogen ions, and therefore relatively higher concentration of hydroxide. Okay, so what happens? See, when you have a lot of hydrogen ions compared to hydroxide ions, They will react together to give you neutral water molecules. But what about these remaining hydrogen ions? They are left unreacted. They will contribute to they will remain in the solution giving low pH. Why? Because of high concentration of hydrogen ion. Same is the case here. Same is the case with these hydroxide ions. The concentration of hydroxide ions is too much compared to hydrogen ions. Okay, so now this hydroxide will compare with hydrogen ion giving water molecule. Okay, these are the remaining hydroxide ions which will lead to higher pH. Okay, so I hope you understood this. Now, one last thing that I want to explain. I think I have covered most of the important points. I want to discuss this experiment 10.1 on this page. I want to discuss this. This is simple. They just want to tell you the color of the indicator. And I think they're using universal indicator. In this experiment 10.1, they're using universal indicator, and they're just showing you the color of universal indicator. Now, this is my conical flask. Also, you should be able to identify the apparatus. I hope that you have done it in midterms. This shaped flask is a conical flask. This is a conical flask. Okay, now I already have 10 cm cube of sodium hydroxide. Okay, also pay attention to the equation. This is how they react. This is hydrogen chloride reacting with sodium hydroxide. Okay, basically the cation, because of the attraction between opposite charges, the sodium will bond with chloride, forming the salt, and hydrogen here is positive, here is negative, because of attraction between opposite charges will give me water molecule. Both of them are neutral. They will bring the pH to 7. Remember, pH 7 was neutral. They will bring the pH to 7, meaning all the hydrogen ion is neutralized by all the hydroxide ions to make the neutral water molecule, right? This is the reaction going on in here. So now come back to this. They have added a known volume of, this is alkali. Remember what alkali was? A soluble base is an alkali. Okay, Ibrahim, I will take question from you. Let me just finish this off and then I will take question from you. So this is an alkali. Remember, alkali is a soluble base. I took a known volume, 10 cm cube. I measured it with the help of measuring cylinder or any measuring apparatus, and I poured in 10 cm cube of sodium hydroxide along with universal indicator. Why? Because I want to see the change of color as I pour in acid. That's why I have already added universal indicator. Just 5 drops would be enough, not too much. Okay, because even 5 drops will give me enough color change. Okay, now 10 cm cube, right? 10 cm cube. I directly measured 9 cm cube of acid. Again, I can use a measuring cylinder, or there's another instrument I can use, which is burette. Okay, what is a burette? How does a burette look like? Let me show you. Let me show you how a burette looks like. I am sharing this is what a burette looks like. Okay, so can you see the nozzle? By unscrewing and screwing, I can regulate the drops of acid pouring into the conical flask. Okay, and I have to be careful. Why do I have to be careful? Why do I have to be careful? Because I want the seesaw to be exactly like this. I don't want, here is alkali and here is acid. I want them to exactly balance each other out so that I have exactly neutral water and sodium chloride. Now, if by accident, if accidentally I add more acid, even 1 drop, even if I, by accidentally, if I add even one more drop of acid than what is required, my seesaw would get this way. My seesaw would get this way. And I don't want that. I don't want this. So what do? I know that because they are, you know, one molecule of HCl requires one molecule of sodium hydroxide to give me one molecule of water and one molecule of sodium chloride. Therefore, I know 10 cm cube of sodium hydroxide should be neutralized by 10 cm cube of acid. So after I have added 9 cm cube of water, I will observe the color. So initially, when I only had alkali, the color was purple. Remember, purple is pH 13. Sorry, this I don't know what color is this, like something like violet, purplish, pinkish. Yeah, this shade of 13, right? Now I know that this is alkaline. Now when I added acid, I got somewhere here, maybe 9. I got somewhere here 9. Now I want exactly 7. I want exactly 7, this light green color. So now I got to be real careful. Only one more cm cube, right? I've already added 9. I want to add one more cm cube, but I have to add that 1 cm cube really carefully with great caution, drop by drop. And after the addition of each drop, I will swirl. You know how you swirl? Like this, swirl like this way, okay? And because it will be as transparent, I mean the conical flask, you should see it against sunlight, against a window, sunlight, so that you can see the slightest change. Because this color will change instantly, in matter of seconds. And you might add by accident more acid than what is required, and that will make the whole thing acidic rather than neutral. This is neutral. I want this. I want my seesaw to be this. Okay, so drop by drop and swirl after each drop and look for color change against sunlight. Okay, because we want only salt and water. We do not want any unreacted acid left behind. Okay, now let me give you another analogy. If, for example, a shopkeeper is balancing, you know, or for example, I'm balancing and I know I have something here that I want to measure. How much is this? Okay, for example, this is my seesaw and this is what I'm trying to weigh, right? Now I know, for example, that this is 4 kilos, 4.5, for example, this is 4.5, okay? Now, if I want to balance this seesaw or this marker, whatever, my balance, I will add 4 kilo with no problem at all, because this is 4 kilogram and something, 4.5, right? So I can easily add 4 here. But then for 0.5, I have to be careful. I will slowly and gradually add grams till I see that this is balanced. So it's the same way. They added 9 cm cube of acid real easily, but then for the last 1 cm cube, they told you to be cautious because you don't want to be even 1 drop above that 1 centimeter, so that the seesaw is absolutely balanced. Okay, I hope I made sense. I hope you guys understood what I am trying to explain you. So if there's any question, ask me. If the pH is 1, 2, 3, 4, the concentration of hydrogen ions would be higher. Yes, Riaz, you are right. If the pH is 1, 2, 3, 4, meaning from 0 to 7, from 0 till 7 till 6, yes, the hydrogen ion concentration is greater than hydroxide ions. Okay, by the way, hydroxyl is for hydrocarbons, okay, organic chemistry. So hydroxide is what we use in inorganic chemistry, okay? Okay, if the pH is 8, 9, and 10, the concentration of hydrogen ions would be lower. Yes, Riaz, you are right. If the pH is above 7, 8 onwards, that means the concentration of hydrogen ions is less and the concentration of hydroxide ions is greater. Okay. Okay, Ibrahim. Okay, I'm sorry if, okay. So is there any other question? We are out of time. I wanted to do some end of chapter questions. Can we do them real quick? Just a little. Let's see. Let us do a simple one. A simple one. Question number 5. At the end of chapter, question number 5. This question. The table below shows the conditions some plants prefer. Which plants grow well over the largest range of pH values? Over the largest range. Now, what does range mean? They have written range in bold. Range means the figures which are farther apart from each other on the scale, which are farther away from each other on the scale. So basically, an easier way of doing this is you subtract the smaller number from the bigger number. You subtract the smaller number from the bigger number and write down your answers here. 6.5 minus 5 is 1.5. So write 1.5. What will be this? So you write down all the differences here, subtract the smaller from the bigger, and the one which will give you the biggest difference, that means that range is the largest. So that plant would be the one growing over the largest range of pH. Okay, I will also share with you guys the answers to the end of chapter questions of this chapter, okay, in the group. And you can use that as reference, but remember, knowing the correct answer is not the end of the story. You should know why that answer is correct. Okay, you should be convinced by that answer. Now, which plant can grow in the most acidic soil? Most acidic. What will you look for? Yes. Ibrahim, you want to answer? Yes, Ibrahim.
The most acidic is can I get apple?
Apple. Look at the lowest values. Look at the lowest values and compare which one is the smallest.
Potato.
Potatoes, right? Potato. So potato should be the right answer. Okay. Describe how, part C, describe how you can test the pH of a soil. Yes, who can tell me? Okay, let me see. Me, Riaz. Okay, Riaz, where are you? Yes. Yes, Riaz.
No, I was trying to answer the part A.
You can't tell me part C?
I'll try.
How can you test the pH? Okay, Amara. Yes.
Add 50 centimeter cube of distilled water to some acidic soil. Stir it well, filter, then add a few drops of universal indicator. Add powdered limestone until you neutralize the solution.
Okay, I understood why you added universal indicator. Universal indicator was now. Okay, were you reading? Yeah. See, Rita, you have to give me answer in your own words. See, this is, am I sharing my screen with you? Can you see my screen?
Yes.
What can you see? Can you see the answer?
No.
No, you cannot see the answer. Okay, let me. Sorry. Okay. Now can you see? Now can you see?
Yes.
Yes. So part C, shake some soil with distilled water. Why did we shake the soil with distilled water? See, we are trying to test the pH of a soil, right? If we want to find out the pH of a soil, we need to measure the concentration of hydrogen ions, right? And hydrogen ions will only be released in a solution. So to turn this into a solution, we need to add water. So that is why we added water, right? Shake some soil with distilled water. So that's why we added water. Because why? Because we wanted the ions, hydrogen ions, to come out so that we can measure their concentration, right? Then we filtered the mixture. Why did we filter the mixture? To get rid of the soil particles, the solid soil particles, so that we only have the hydrogen ions with us, the concentration of which we will measure. Then we add universal indicator to that what you got out of filtration, what you got after filtration, that is called a filtrate. And you will add universal indicator into it, and the color will tell you. If the color is pinkish, that means more hydrogen ion concentration, mean acidic soil. If the color is purplish, then that means less hydrogen ion concentration, more hydroxide ion concentration. So that means the soil is alkaline or basic. And if it is green, then that means the soil is neutral, so on and so forth, right? Did you understand? Okay, how can you raise the pH of an acidic soil? So how can we raise the pH? Oh. How can we raise the pH of a soil, of an acidic soil? Common sense, common sense. Use the chat window. Okay, Riaz, you want to answer this? How can we increase the, yes, Hassan. Yes, Hassan.
Teacher, in our book, there's a different question. It's written, what should be the highest concentration of hydrogen positive ions in soil used to grow mint?
What should be the highest concentration of hydrogen ion in?
Soil used to grow mint. This is
Oh, used to grow mint. Yes.
question 5.
Okay.
It's in our book.
Okay. So the highest pH is 8, right? And in the answer key, they have given the concentration to be 1 × 10⁻⁻⁷. Oh, but they haven't explained this to you, how to convert the pH into concentration. Have they? Have they talked about it? No.
No.
Yeah. So if they have not explained you how to convert the concentration into pH, I don't think it should be included, and I don't think you should be expected to know that. So let's just skip it, okay? But this is a more sensible question. This is a more sensible question. Look at this. Where am I? My question is more sensible. The question in my book, how can you raise the pH of an acidic soil? So how do you raise the pH? How do we raise the pH? Look at this pH scale. So if we have more hydrogen ion concentration, the pH is low. If you want to higher the pH, just add something alkaline. Just add something alkaline. Yes, that will decrease the concentration of hydrogen ion and increase the concentration of hydroxide. What can that be? Yes, that can be for soil. We cannot add hydroxides for soil. Well, this part also we have not done yet. Okay, this is this last part, this acid soil. This part, when it gets too acidic, then we add calcium carbonate. So calcium carbonate, by the way, when it dissolves in water, it ionizes the water to release hydroxide and therefore raises the pH. So we have not done that as yet. Okay. So that's that. We will discuss the rest of the questions later. We are already ahead of time. So if there's any question, ask me. Otherwise, I will end the meeting. And next class, we will discuss salts. Okay? When do you guys want the next class to be? I'm asking everybody.
The same.
Yes,
Yes?
Ibrahim Tasif answered wrong. It's blackcurrant, not potato.
Is it black current?
Yes,
Okay,
this-
I have
this
not
could be-
calculated this
I
out.
think that ठीक था.
It's okay, it's okay. It's okay. We are all
I answered for B.
wrong. Okay, but
I
tell me,
मैंने
when
B
should I
के लिए
take the
answer
next
किया था
class?
रियाज.
Okay, please, in the chat window or in the group, you can suggest when should I take the next class. I have only Sunday free, Sunday in the morning, Sunday afternoon, like same time, 4 p.m. I'm free. That's the only time I have. The rest are all taken already. So if you want me to do this salt chapter, so salt part of this chapter next Monday, then you let me know. Otherwise, we can do it on Sunday. I mean, we can just finish off this chapter and then we can do questions. So it's up to you. Any afternoon time is good. Okay, good. But Sunday or Monday, I mean, how many classes do you want in a week? One or twice? Once? One class is enough or two? Two classes. It's up to you. Let me know. Okay, you guys can let me know in the group or here in the chat window. Okay, one class. Okay. Okay then. Okay, I'm ending the meeting. Okay, assalamu alaikum wa rahmatullahi wa barakatuhu.
The host has Allah Hafiz.
Allah Hafiz.